I see 15 of you have voted. By the way, how come they are getting lesser and lesser students in the class? Okay, so 12 person have completed the question. So maybe today we can discuss some questions. Okay, let's start to discuss our answer right now. So last week we have discussed about the question 1. Then today we are going to discuss the remaining question. So after that we will be proceeding to the another set of the question, okay, or the passive question. Okay, let me turn on my slide first. Microelectronic slide about lecture 5, lecture 6. Okay, so let's see. So with the aid of the diagram, explain the Hall effect and how the Hall effect device identifies whether the semiconductor is a p-type or an n-type. So this one, it contains about 14 marks. To answer this question, you need to draw the diagram of the Hall effect device. So to draw the Hall effect device, you can refer to the lecture 6, then go to the middle, okay, and then try to draw all these devices, okay, sorry, including all the label, for example, like the VH, the length, and then the IX, the VX, then how it induce the induce the Hall voltage. Okay, so this is the question and the answer. So basically, to get these full marks, all you need to do is to draw everything correctly. Okay, we will start thinking and label all these things. Each of the thing will contain 1 mark. Okay, if you label all these things correctly, then you should be able to get partial marks. And then don't forget, there is also the second part. Okay, how the Hall effect device identifies whether the semiconductor is a p-type or n-type. So in order for you to identify whether it's a p-type or n-type, you need to use this formula. Okay, if your Hall voltage is a positive, this is the p-type. If the Hall voltage is negative, this is the n-type. So in order for you to answer this question, you need to draw this diagram, then answer in this way. So you should be able to get a full marks. So this is the 2A. So let's see 2B. Consider a silicon at the T equals to 300K. A Hall device is fabricated with thickness D 2 times 10 to the power negative 3 cm, then W 2 times 10 to the power negative 2, L 0.6. All these things we look at A is cm, cm, cm. Current Ix 0.6 MA. Voltage 1.5. Quotient, this one the magnetic field 6.5 times 10 to the power negative 2. EH is negative 81.25 MV/cm. Okay, first part. he asks you to calculate the Hall voltage. In order for you to calculate the Hall voltage, you need to use the right formula, which is the EH multiplied by W. Okay? Or you can use this way, IX. You can see whether if the IX is given, IS is given, BZ given, D given, but we don't know about the P. Okay? P we don't know that yet. D we know. So in order for us to calculate that, we need to use this VH multiplied by the EH and then W. W is the width, which is 2 times 10 to the power negative 2. But one thing you have to know that when we are doing this Hall effect thingy, we need to convert everything into the SI unit. So you can see that originally everything is in the cm. You need to convert it back to the meter. Okay, this is how we are going to do it. So let's see. B1. Who can answer me the question B1? Ku Mun Kyung, are you here? Ku Mun Kyung? Mr. Ku Mun Kyung, are you here or you already MIA missing action? Okay, never mind. Lim Chun Wei. Right. You didn't convert to SI unit. Okay, so I assume that all the question will be wrong. Lim Chun Wei, what about you? You hear Lim Chun Wei? Okay. Han Xiang, what about you? Okay, negative 1.625. Are you calculating this in the SI unit? Okay, good. So if you are calculating in the SI unit, supposedly you are going to get the same answer as the Han Xiang. Okay, how many of you get negative 1.625? Okay, that's yes. And V, sir. Okay. Okay, just one thing that if this one is in the cm, so you also need to calculate in cm. If it's m, you calculate in m. Okay. So I skip this. I go to the next question. Let's see the next part. Oh, like this. Determine the conductivity type. So this is either the pair p type or the n type. So from the EH, you can know that this one is a negative value. You can directly get 3 as a negative. Okay, this is the n type. And then you will ask to calculate the major carrier concentration. What are the majority carrier concentration? So in this case, we know that this is a negative value. So we can know that this is an n-type semiconductor. We are going to calculate the electron concentration. So in order for you to do so, you need to use the right formula. Okay, which is this. Ix, B, E, D, and also the VH. Also, don't forget, everything must be converted in the SI unit, including this EH. But since this EH, when you are calculating the VH, this one is negative, sorry, EHW. But you can see that this one is a MV over CM. So your W can be also in the CM as well, because it will eliminate each other's. Okay? But this one, negative 1.25, you must be multiplying with the 10 to the power of the mini. Okay? So this is the way you do it. So you can look at some of the example like last time. For example, this one. Okay, you can see that this one is the N IX. IX is originally 1.0, then times 10 to the power negative 3. Everything must be converted. Then this one is a B. B is the times 10 to the negative 2. Then this one is the 10 to the power negative 5, which is the D, if I'm mistaken. Yep. So this is where you are going to do it. Okay. Anyone can answer me what is your electron concentration? Hu Heng Dong. Are you here, Hu Heng Dong? You calculated in cm. Okay. Okay. Let's make a quick survey. How many of you have converted into the SI unit? SI unit. Yes and no. And then launch. Okay, let's see how many. Okay, just work now. Mm-hmm. Okay. Okay, more than half. Okay, so right now I want you guys to calculate this in the SI unit. Recalculate the question 2. Okay, just the question 2. Change everything into SI unit as mentioned in this. So if this kind of question come out in the exam, so everyone can, I would say. Okay, try it. Okay, please vote after you have done the question 2 by using the SI unit. Okay, so since everyone already, more than half of you have completed this question, so let's proceed with the answer. So I believe right now you're already using the SI unit to calculate the answer. So what's your N? Can anyone tell me? Let's pick a guy. Lu Jiaming, are you here, Lu Jiaming? What's the answer? 7.5 times 10 to the power of 21. So I guess this one is in the meter minus cube. After that, you maybe convert it back to the cm minus cube, which is about negative 6, about 15 minus cube. Okay, for the rest of you, do you get the same answer? Okay, plus 1, plus 1. The remaining one? Okay, plus 1. Okay, so I think this one, not much problem. Then go to the third question. Sorry, question number 4, Q24. Calculate the majority carrier mobility, mu. Okay, what is the mu? Wong Ga Seng, what's the answer for this mobility? 0.5. The rest of you, do you get the same answer as your friend Wong Ga Seng? Okay, so don't forget to write back the unit. So I believe this one should be in the m square VOS. You didn't convert back to the cm, right? Okay, you should be in this kind of format. So basically, this is the way we do it. Very simple and easy only. Okay, then let's go to the question 3. The probability of an energy level being empty of an electron is 99.33%, and the state is below the Fermi level by E. Determine the E in terms of kT, where the kT is the Boltzmann constant and the T is the temperature in the Kelvin. Okay, in order for us to do this, we have doing it by quite some times, which is you can refer to the question slide 3. Go to the end. The formula is somewhere around here. Okay. So this is the formula. So based on the question, we know that this one is the empty one. Wait. Okay. So this one is being empty. State is below this. Then determine this KT. So when you are going to refer back, you can refer back to some question example like this. Okay. This one occupied by an electron. You are using the positive one. So when this one is empty, okay, you need to use the 1 minus 1 over 1 plus exponential E minus EF over KT. If you still remember this formula. Okay, double check. It looks something like this. Okay, just that you need to use 1 minus. And then your answer is 0.9933. Okay, give me 1 minute. I pick up a call. Okay, let's get back to here. So basically, you are going to use this formula. So you use this 1 and then minus 1 minus 0.9933 1 plus exponential E minus EF over KT. And based on the question asks you to express the E in terms of the KT. Okay? Which means that you are going to shift this formula to the right one. So what is the value of 0. Okay, where 1 minus 0.9933? You get 0.0067 equals to 1 plus exponential E minus EF over KT. And then 1 plus exponential E minus EF over KT 0.067. Okay, 1 divided by 0.0067 will be, you get 149. Okay, E minus EF over KT, you get 149 minus 1, something like that. Okay, I do the rounding. And then let me expand this area. And then this one is a exponential E minus EF over KT 148.25. Then you try to do the exponential. Okay. So in order for you to do this, you need to use the then ln both sides, natural logarithm. Okay. So let me calculate it. Okay. Ln 148.25, you get 4.99. So E minus EF over KT is about 4.99, is about 5. So eventually your answer will be E minus EF will be about 5 KT. Approximately. Do you get the same answer as me? Okay. Something like this. Or you get different answer. Okay, so this one is simple and easy. Okay, let me drink water first. Okay, let's continue for the next question. So the next question, it will need you a little bit of the derivation if I'm mistaken. So let's see. Okay, so the E1 equals to E2, where E1 representing the occupied energy state above the Fermi energy level, you are both having the same probability. Okay, how are you going to do this? So let's say we have a P. P equals to 1 plus exponential E minus EF over KT. Okay, this one E1 will be equals to 1 plus exponential E2 EF over KT. Okay, he's saying that if both E1 and E2, he want to prove that E1 is this one equals to E2 when both are having the same probability. Okay, so let's try to play around with this. Okay, so one trick that you have to know is there must be this one. He assumed that this one E1, this one E2. E1 same as the E2 so that you can have the same probability. How are we going to do this? All you need to do is you need to assume that this is the negative value in this part. Okay, because this one must be below 1. If you are putting the below 1, this one must be always the negative. So this is negative E2. This is E1, positive. So we can start doing it. 1 plus exponential E1 KT equals to 1 minus 1 plus exponential negative E2 over KT. And then we start to do the rearrangement. 1 plus E, let's say we put it as an S, easier. So 1 plus E y, we put in this way. Easier to visualize and do the calculation simpler. Okay, then we are trying to do the multiplication. 1 equals to 1 plus EX minus 1 plus ES, 1 plus EY. And then we try to move here. 1 plus EY equals to 1 plus EY plus EYES. Yeah, 1. Okay, sorry. So this should be the ES plus ES EY. Okay, then minus 1 minus ES. So basically, I just carry forward to here, then do the multiplication. Then negative we put inside here. Okay, then we start to do this one did it, ES did it, EY did it. Okay, eventually we'll get this ES EY. Okay, and then ES EY. ES is equals to the exponential E1 KT exponential negative E2 KT. Okay, so you can write in this way also. E1 and then minus, sorry, you can write this way, E1 KT, and this one is a E, negative E2 KT. Then you move this to a downward, 1 over E2 KT will be equals to the E1 KT. I skip the triangle, I don't want to keep on rewriting it. So you just flip back to the above, you will get this E1 KT will be equals to the E2 KT. So by having this, you can prove that E1 will be equals to the E2. Triangle, triangle. Can you understand? Can you follow? If you can follow me, type a yes or you type a +1. Okay? Or you need me to repeat again, I can repeat. Okay, so some are request to repeat. Okay, so I remove everything. So the question asks, show that E1 will be equal to the E2 if both are having the same probability. Okay, from the diagram, one is the above, one is the below. One is occupying, another one is the empty. So this is the E1. This is the E2. Okay, so the probability, so both are the same. If both are having the same probability, okay, which means that the above one will be 1 plus exponential E1 over KT will be equals to 1 minus 1 plus exponential, and you have to put the negative E2 here. Why? Because this one is below. Okay, they are supposedly to be the negative value. Okay, give me 5 minutes. Many calls today. Okay, we just repeat, we just continue here. So this will be equals to the over KT. So transition, this part, are you okay? This part okay? Okay, then we try to denote this part. Okay, this part will be S. Sorry, ES. This part we write as a EY. Make it simple. 1 plus ES equals to 1 minus 1 plus EY. Okay, then we try to expand this formula. Okay, we might try to move this above first. Everything multiplied by 1 plus ES, the whole formula. So this will be 1 plus ES minus 1 plus ES, 1 plus EY. Okay, transition, this part okay? Clear? And then second part, we are going to multiply the whole formula with 1 plus EY. Whole formula. Then this one will be 1 plus EY. Then this will be 1 plus EY plus ES plus ES EY. Okay? Then minus 1 minus ES. This part okay? Then we try to remove this one can be deleted. This one can be deleted. This one can be deleted. So we left 1 equals to ES EY. Okay? Then we just simply need to shift either one to the below. In this case, we are trying to shift the EY to the below. ES will be equals to 1 over EY. This part okay? Okay, then ES will be equals to this. Exponential E1 over KT. So this will be 1 over exponential minus E2 over KT. This part okay? Since this is a negative, 1 over E negative 1 will be equals to E to the power 2, right? Simple mathematics. You just simply need to shift it on the top. E2 over KT. So eventually E1 will be equals to E2. Okay, proof 1. Transition, okay? Okay, everyone clear? Okay, if clear, then I proceed to the next question. Okay, consider the energy level shown in the figure Q3A, given E1 minus EF equals to 0.8. Then determine the probability of the energy at the state at E1 is occupied. Then this one calculate the E2. Okay, and then try to do the question. So from the question, we can know that. Let me remove every single item here. Okay, E1, EF, E2. This one is the 1.32, 0.868. So the remaining one, can you calculate it? So this is the 1.32 minus 0.68. 1.32 minus 0.68. Hey, can I cut? Where 6. My calculator hang already. Don't know why. 1.32 minus 0.68, 0.64. Okay. Then you are going to use both of the formula. 1 plus exponential. So E minus EF, in this case 0.68 over KT. KT. So this T is in the 300K. So we can directly use the 0.0259 to get our answer. So the second one, we need to use the 1 minus 1 plus exponential. And this one, since this one is the below 0.64, so this is the negative 0.64 over 0.0259 to get the correct answer. Okay, so what is the answer? So let me pick two guys. Tiêu Long Ho, what is the answer for the question C1 and question C2? Mr. Tiêu. Tiêu Long Ho, are you here, Tiêu Long Ho? Okay. Okay, the above one is the 3.92 and 95 times 10 to the power negative 12. Any plus one? Or you get a different answer. Let's say plus 2, I'm guessing. Okay. Any plus 3 or plus 4? Okay, cool. Tiêu Long Ho, what about the second part? The below. Okay, let's wait for our friends to answer the question. Okay, this is a 1.855 times 10 to the power negative 11. Do you guys get the same answer? Okay, plus 1. Okay, cool. So let's go to the next question. So this one is just a simply theory by zero bias, forward bias, and reverse bias. So I'm not going to discuss about this. So let's go to the last part. So this one, I think we have done it several times. So let's see what's it. So this is a zero bias case. Then we get an NA equals to 5 times 10 to the power 15. And D is 4 times 10 to the power of 16 cm minus q, cm minus q. Then this one already gives you the direct dielectric constant, 103.545 times 10 to the power of nearly 14. So calculate the VBI, then SN, SP, and then if the reverse bias is a 5 volt, if reverse bias at first this one all are zero bias. So if the reverse bias 5 volt, what are the W? And then the Emax, okay, based on the reverse bias. So let's pick some guys to answer my question. Kwa Yi Hang, what is the question of the, what's the answer for question 1, 2, and 3? Okay, tell me the VBI first. Okay, 0.71126. Do you guys get the same answer? Last one. The rest of you, Yong Qie, do you get the same answer? Okay, Ng Han Xiang say yes. Okay, then what's the SN? Yong Qie, what's the answer for the SN? Okay, 5.0616 times 10 to the power negative 6 cm. Do you guys get the same answer? Okay. Chu Zhang Heng, what's the answer for the SP? Okay, 4.049 times 10 to the power of negative 5 cm. Plus 1. Okay. Okay, then what about the W and the Emax? Lou Jianglian, are you here? What's the answer for the W with the reverse bias case? Okay, this is a 1.2898 times 10 to the power negative 4 cm. So do you guys get the same answer as your friend? Well, your E is quite big. 8.85 times 10 to the power 14. Do you guys get the same answer? You guys get a different answer. Han Xiang, what about you? W same. The Emax. Okay, so I believe W is the same. What about the Emax? Han Xiang, your Emax is? Okay, I believe the one given by Han Xiang is more correct. Emax won't be that big. Lah. If Emax so big, then I think the machine burst already. So do you guys get the same answer as the Han Xiang one, the Emax? Okay. So I think that's all for the SM passive question. So today maybe this one is just a simply just a theory. I will explain it. Okay. Today just we can end earlier today. Then the next class we are going to do another set of the passive question. Okay, to familiarize with the situation. Okay. If there's no further question, then we can dismiss the class now. Thank you very much. Have a nice day.